Hey, welcome back to the course. And in this lecture, let's see why do we study about this ARM Cortex M processor. So let's build up some motivation to learn about this processor. This processor is an embedded processor, and it is used in most of the microcontrollers you see today, and used in wide ranges of embedded applications like battery-powered devices. Examples are health monitoring and fitness tracking applications, medical meters, etc. Automotive applications, IoT applications, mobile and home appliances. It is used in toys and consumer products, PC and mobile accessories, and there are huge application area where this processor-based microcontrollers are heavily used. For example, consider a product from Fitbit, called Fitbit Flex. It's a wearable device actually used for fitness tracking, and it has got wireless connectivity also. And this uses a microcontroller produced by ST Micro, and the processor used is the ARM Cortex M3. And ST has produced lots of microcontrollers which are based on ARM Cortex M processor, which they use to target the ultra low power application. And here is another example, so which is TomTom's Spark 3 GPS fitness watch, which is powered by Atmel's Cortex M7 based microcontrollers, what they call as Atmel's smart microcontrollers. Okay, so the processor used is ARM Cortex M7, and the application type is also battery powered in ultra low power application. So most of the famous MCU manufacturers produce microcontrollers based on ARM Cortex M processors. There are many manufacturers they produce microcontrollers based on ARM Cortex M processor, and they all target different application area. For example, TI targets low power battery based applications. Toshiba targets measuring equipment, metering devices. Broadcom targets IoT related applications based on wireless connectivity like BT, Wi-Fi. ST Micro targets all high performance, medium performance, as well as low performance applications. So they have got different microcontrollers to target all these application area, and most of them are based on ARM Cortex M processor. All right, so, and there are many such manufacturers, so I have just listed a few, okay? And most of the manufacturers, they love to use ARM Cortex M processor in their design because of its minimal cost, minimal power, and minimal silicon area, okay? So they can save money when they produce microcontroller. They can reduce the silicon area, and also they can design a microcontroller which can target different power requirements. And ARM Cortex M processor is a 32-bit architecture which will surely boost the computational performance of an application compared to 8 and 16-bit processor-based microcontrollers. And it comes with almost same the price of 8-bit or 16-bit traditional processor. Okay, so instead of buying 8 or 16-bit processor-based microcontroller, you can switch to a 32-bit processor-based microcontroller for the same price, and you can have lots of other advantages. Okay. And you can use this processor-based MCUs in ultra low power to high performance-based applications. So the processor is customizable for the manufacturer of the microcontroller to include floating point unit, DSP unit, memory protection unit, and so on. So the manufacturer of the microcontroller, they can customize this processor to include various other units depending upon the application area they target in the market. Okay, and it has got very powerful and easy to use intercontroller which supports 240 external interrupts. So about which you will come to know later in this course. Okay, all right. So now, next important feature of this processor is it is RTOS friendly. That means it provides some of the exceptions, processor operational modes, access level configurations, which helps to develop secure RTOS related applications. Okay, so this has got various operational modes, different access levels, so about which you will learn later in this course. Okay, all these features actually help to develop secured embedded OS or RTOS related applications. Its instruction set is rich and memory efficient. The ARM Cortex M processors use thumb instruction set, which is collection of 16-bit as well as some 32-bit instructions. Cortex M processor cannot execute the ARM instruction set instructions. Okay, the ARM instruction set instructions are actually of 32-bit. Okay, so it actually uses thumb instruction set, which gives the same 32-bit ARM instruction performance but in 16-bit format. So that saves a lot of space in the core memory. Okay, and ARM provides lots of documentations like technical reference manual, okay, user guides to explore more about this processor. Okay, so you just have to go to infocenter.arm.com in order to browse various documentations related to ARM Cortex M processors, and you can explore more always. Okay, and there are some major competitors for ARM also. One among them is AVR-based 8-bit, 16-bit, and 32-bit microcontrollers. So these are produced by Atmel. Now it's called as Microchip, and most of the Arduino boards you see in the market, they use microcontrollers which are based on AVR processor core of 8-bit, 16-bit, or 32-bit architecture. Okay, so only one board I think that is Arduino Duo, which is based on ARM Cortex M based processors. So the rest all are actually based on AVR processor architecture. Okay, and also MSP430 microcontrollers produced by TI, so which also doesn't use ARM based processor inside. Okay, so they use their own processor architecture. Okay, in MSP430 microcontrollers. Great, so that's a little motivation to learn about this processor, and as we make progress in this course, we'll learn lots of features of this processor, and we will write some code in order to test all those features on our target board. All right, so I assure you, you will learn a lot of things related to this microcontroller hands-on, okay, in the subsequent lectures of this course. So with that note, I will end this video and I'll see you in the next lecture. Hey, welcome back to the course. In this lecture, what we're going to do is we're going to understand about the differences between the processor core, the processor, and the microcontroller. Understanding these terms are really important in embedded systems because most of the time we use these terms, in a wrong way, so which leads to lots of confusion. Okay, great. So now let's get started. All right, so to understand about the processor, the best place is always to check the official document from ARM. The ARM releases something called the Technical Reference Manual, which is called as TRM, about the processor they design and release to the market. Okay, and these documents are available in ARM's website, and it is open to all the users so that we can download it and check the details about the processor. Okay, so and believe me, this is the best place to start understanding about the processor. Okay, so now I'm directly taking you to the technical reference manual of the ARM Cortex M4 processor. All right, so in this document, okay, if you just click on the functional description, okay, section of this document, so you will be seeing this nice diagram over here, so which is nothing but the block diagram of the Cortex M4 processor designed by ARM. Okay, and this processor clearly indicates that a processor is nothing but a processor core which is surrounded by lots of peripherals. Okay, that means the processor itself is made up of a core with supportive processor specific peripherals which is designed by ARM. Okay, so in this diagram you can see that Cortex M4 core is surrounded by various peripherals such as the NVIC engine, the flash patch breakpoint, the bus matrix, the memory protection unit, the data watch point and trace unit, and so on. So it is actually surrounded by lots of processor specific peripherals. Okay, great. So now the question which may immediately trigger in your mind is what exactly there inside the Cortex M4 core? So the Cortex M4 core is actually the basic computational engine of the processor. It consists of its own register sets. Okay, it consists of the ALU where the computation takes place. It consists of the barrel shifter. It consists of the pipeline engine, various registers to manipulate the data, the special function registers to track the execution state of the core. It consists of instruction decoder to decode the instruction. It fetches from the program memory and it checks whether it is indeed a valid instruction or not. So all these components are actually the part of the core. Okay, so the processor is also called from the term CPU, which stands for the central processing unit. Okay, and this is called as CPU core. A CPU may have multiple cores. Okay, for example, the Cortex M4 processor or the Cortex M4 CPU consist of only one core, so that's why it is a single core CPU. Okay, great. So that's the difference between a processor and a processor core. A processor is nothing but the processor core plus the surrounding processor specific peripherals. Okay, so in this course we'll be studying some of the processor specific peripherals in detail. For example, NVIC, okay, which is there for handling various interrupts and exceptions. Okay, so we will discuss this peripheral in detail later. Okay, and we will also discuss the bus matrix of the processor later in this course. And also note that the Cortex M4 processor talks to the external world through various bus interfaces like I-code bus interface, D-code bus interface, and the system bus interface, which we will study in detail later in this course. Now, in the next lecture, let's see what is the difference between a processor and a microcontroller. Hey, welcome back to the lecture. So in the last lecture, I was explaining about the block diagram of the Cortex M4 processor. And remember that the Cortex M4 processor is designed by ARM. That means processor core, all its associated peripherals are actually in the software IP format, which will be passed on to the various microcontroller manufacturers like the ST Microelectronics, Texas Instruments, NXP, Microchip, Broadcom, etc. Okay, so the software IP of this design, okay, will be purchased by those microcontroller manufacturers, and they will integrate this engine into their microcontroller, and while integrating this engine, that means this CPU design with their microcontroller, they may remove some of the components from this design. For example, they may remove the memory protection unit. Okay, they may remove the data watch point and trace unit. Okay, great. So now let's see what exactly is the difference between a Cortex M4 processor and a microcontroller. Okay, so to understand this, let's take an example of a microcontroller which is there in the market. Okay. All right, so now let's take an example of this microcontroller STM32F446RE, which is actually designed by the ST Microelectronics, and they say it's a Cortex M4 core with DSP and the FPU unit. Okay, so that means if you go and check your block diagram, okay, here you can see that the Cortex M4 comes with optional floating point unit. Okay, the manufacturer may wish to implement this engine, or they may remove it. Okay, so it's highly dependent on the manufacturer. Okay, so they can include it or they can exclude it. Now what we'll do is, now let's check the block diagram of this microcontroller to understand in detail. Okay, so here I have the data sheet of this microcontroller, and in this document you will find the block diagram of this microcontroller. Okay, so don't try to open any document at your side. Okay, so just listen to the lecture. Okay, you may be having similar microcontroller or entirely different microcontroller from some other manufacturer, but don't worry about that. Just look at the block diagram of this microcontroller. The heart of this microcontroller is a CPU, okay, which is nothing but ARM Cortex M4. Okay, so this unit, okay, is actually taken from the ARM. Okay, and the rest all is implemented by the ST. So, and if you go back to your block diagram of Cortex M4 processor, this whole engine is nothing but this one. And take a look into this block diagram. This Cortex M4 processor, as I said, it talks to the external world by using its 3-bus interfaces, that is I-code, decode, and system bus interface that you can see here. Okay, so this engine, that is this CPU engine, talks to ST's implementation, okay, by using 3-bus interfaces, I-bus, D-bus, and S-bus, which we'll discuss later. Okay, so don't worry about that. Okay, so here this is a software IP given by the ARM, and these implementations are actually done by the ST, and they both meet at these bus interfaces. Okay, so now what I do is, now let me take another example of different microcontroller. Okay, so in this case, let me consider a microcontroller from ST again, okay, which is this one, STM32F030R8. Okay, and if you open the data sheet of this microcontroller, you will also see one block diagram of this microcontroller, so which is very similar to what you have seen previously. Okay, and here also you can see that, okay, there is a CPU block, okay, which is nothing but Cortex M0 CPU in this case, because this microcontroller, that is STM32F030R8, okay, which is this one, okay, is based on Cortex M0 CPU. Okay, great. So now let me take another example from Texas Instrument. Okay, so here is a data sheet of Texas Instruments MSP430G2X11 series of microcontrollers. Okay, and if you check the block diagram in this document, okay, so here it is. Okay, so in this case also you will see a block, a CPU block. Okay, but this microcontroller, okay, which is released by Texas Instrument, is not based on ARM CPU. Okay, so this CPU is designed by Texas Instrument itself. Okay, so remember that some of the MSP microcontrollers, they are not based on the CPU, which are designed by ARM. Okay, for example, this microcontroller is based on a CPU which is designed by Texas Instrument itself. Okay, and Texas Instrument also has microcontrollers which are based on ARM CPU. Okay, for example, the TIWA series of microcontrollers released by Texas Instruments. Okay, take an example of this microcontroller, okay, which comes under TIWA series of microcontroller. Okay, so if you just check the architectural overview of this uh, you know microcontroller, you will see that this microcontroller is actually based on the ARM Cortex M4F CPU. Okay, so F means this processor comes with the floating point unit. Okay, so that's why the letter F indicates that. Okay, and if you look at the block diagram of the microcontroller, apart from the CPU part, okay, it has various other parts such as its peripherals. Okay, so you can see various peripherals like GPIOs, timers, the serial communication peripherals, the data acquisition peripherals like ADC, CAN, DAC, okay, timers, okay, and it has various bus interfaces such as HP bus, APB bus. Okay, so all these things we will understand later in this course, so need not to worry about that now. Okay, so our goal is just to understand the differences between the processor core processor and the microcontroller. Okay, and remember that in this block diagram, the ARM Cortex M4 acts like a master. Okay, and all the other peripherals are actually slave to the master, that means to the CPU. Okay, and they both communicate through the various bus interfaces which you are seeing here. Okay, great. So hope you understood about the differences between the processor core, processor, and a microcontroller. Okay, so if you have any questions or doubts, let me know. And if you have any microcontroller, okay, at your hand, please open the data sheet or reference manual of your microcontroller and look at the block diagram of your microcontroller. You will understand various things and find out what exactly is the processor used in your microcontroller. Okay,